sheet that I gave you for all the proofs. Okay, it's the same sheet. Alright. Okay. Definition of a rectangle is a quadrilateral, so 4 sides with 4 right angles. I guess I don't. So we're not in there.
Does that mean it will add up to 360?
Well, it has to add up to 360 because it's a quadrilateral, right? So all quadrilaterals have to add up to 360 regardless of whether they're parallelogram or rectangle or any of those. Okay? Yeah. Oh, they're coming through already? Oh, yeah. Okay. So is a rectangle going to be a parallelogram? Yes. Oh. Okay. Yes. So do all the properties of parallelograms apply? Yes. Okay, so listen. A parallelogram, what's the definition of a parallelogram? 2 pairs of opposite sides are, well, not just congruent. What's the definition? Parallel. So, would we say if this is a rectangle, are the top and the bottom, are those parallel? Yes. Oops. And what about the 2 sides? Are those parallel? Yeah. Okay. Let's look at our first theorem. So if we have a parallelogram that is a rectangle, what do we think the diagonals are going to be? What do you think? They're definitely bisecting, but one additional piece. Simon? They are congruent. So they weren't before. So if it's just a parallelogram that's not a rectangle, think about a parallelogram and think about the 2 diagonals. Look at that diagonal. Is that going to be congruent to this one? Yeah. Yes? No. Isn't this one going to be longer? Yeah. No? It's like stretched out further this way? No, this is just a parallelogram. So if we have a rectangle, think, right, it's upright. We have 2 pairs of right angles. These are congruent to each other. But this one, look at the rectangle, the diagonal here. It's different. Good job. What's that?
We know that just like one side of the line is equal to the other.
Okay, so listen, we know if it's a parallelogram, we know these 2 and these 2 are congruent.
Yeah.
All right? But do we know that the 4 segments are congruent? No. So if we have a parallelogram, the diagonal this way is longer than the diagonal going this way.
Oh yeah, that makes sense.
Right? Bless you. Do you see it?
Yeah.
Because if I measure from here to here and then measure that distance, they're definitely not going to be the same. If I measure this way, I get, that's going to be too long that way. Right? That's much shorter. So when you have a parallelogram and it's like, guys, if it's slanted, right, that one diagonal is longer. So now if you have a rectangle, they're congruent. That makes not just these 2 segments congruent, but all 4 congruent. Right? Because we know not only did all right, guys, I don't think we need that right now. We don't need to, we don't need to strengthen our grip.
So each.
Every. Okay. Okay. Wow. Are we learning geometry right now or exercising? We're exercising our brains. You might need to move. Why'd you move back there? Come on.
I just felt
Okay.
up there. I was like getting too much
It was just too much education up close.
My cortisol levels were like rising too much.
Oh, I forgot we're recording this whole thing. Hi, Maya. Hi, Ellie. Okay. Good morning. Wow. Okay. We're going to prove that theorem. Let's just, Okay. You could write the little rectangular symbol. I'm just going to do this.
When's our testing station?
Oh my goodness. I had it up here. It's on the 10th.
The 10th? That's in a week. Nice job, Jason.
We have 3 more lessons today, tomorrow, Friday. Then we have a review day.
I
Then the
don't think
test.
we have a review day because we don't have math on Monday.
We should have 2 review days.
We have
Yeah.
math on Monday.
Do we not? We don't.
Okay, we're moving on. Number 2. Okay, we're going to prove the above theorem. We want to prove AC is congruent to BD.
So you can say AC is congruent to BD, do the opposite.
What?
No,
You can't prove the theorem with the theorem.
Yeah, Aaron. Can you say that G? Oh wait. Give it like the middle. Of
Okay, I'm going to give you a hint. We're going to try to prove this triangle
90. 'Cause it's a.
is congruent to this triangle.
Can we say it's a right angle?
Yes, okay. So this one and this one, we want to prove those 2 triangles are congruent. Because if we can get the triangles are congruent, then by CPCTC, we can get those 2 sides.
Wait, there's no
Are
like
there,
name
is
for
there going to
this.
be a
It's just
proof on
like
the test?
There's no what?
like this theorem is
I don't
called
know. Probably.
like there's no like
There's no name for it, so we just say a rectangle implies.
Is there going to be a proof on the test? Yes.
Miss Katie, I have a question.
No more.
No.
Okay,
Just
fine.
saying, do opposite angles apply to rectangles?
well, they're all congruent.
Yes.
they're all congruent.
Okay, so
When I
listen.
say angle D is congruent to angle B,
It says all
Okay,
the
listen. If
properties
it's a
for
rectangle, we can use any of the parallelogram theorems. Okay? But I'm going to tell you, we absolutely need to use the definition of a rectangle at some point. Okay? Okay, Simon.
I think Aaron should get demoted out of this class.
Oh my gosh. Real
I
questions.
chose to. I didn't choose.
Any ideas?
It's 3 ice cream.
Do you understand? Do you understand? Yeah. So do you understand what I was saying here? So-
Like, how do they like share something?
Okay, so we're trying to get this triangle here congruent to this triangle.
Oh.
If we can get this triangle congruent to this triangle, then by CPCTC, these 2 sides will be congruent.
But are
Okay.
the ADs congruent? Yeah.
Okay,
Do you
AD
know
is
that?
congruent. We can. So we can say AD is congruent to BC. And the reason is a rectangle is automatically a parallelogram. So all of those theorems, so parallelogram implies opposite sides are congruent.
Can we
Okay, so we have a pair of sides.
say that like the triangle equals 180 for each triangle and then substitute it like triangle BCD equals 180 and triangle ADC equals 180?
Yeah, but that won't get us anywhere. We're trying to prove the triangles are congruent. So saying that they're 180, is that going to get us any? We want like side angle side or angle side angle or hypotenuse leg or something like that.
Or wait, hypotenuse.
Yeah, I should do the angles are
Like you just
Okay.
know, like,
What 2 angles do we need to get congruent? Do you see this and this? If we can get angle ADC and BCD congruent, well, what kind of angles are they? Okay, so angle ADC
like how do you prove it? Like that's just like no.
and BCD are right angles. That is definition of a rectangle. Okay, so you have to say that they're right angles, and you have to use definition of a rectangle somewhere in the proof. Now, once they're right angles, what can we say about them? They're congruent. So here we have a right angle, here we have a right angle. So for angle ADC is congruent to angle BCD. All right angles are congruent.
Could we have just like skipped step 2 and just gone straight into 3?
So 3 and 4 can be before step 2. Step 2 can go later.
Oh,
Now, they happen to share a side. What side do they share? DC.
we should find that out.
What?
Aaron, find that out.
What?
This is reflexive. Okay, we're almost there. We have just 2 more steps. Can we prove the triangles are congruent?
Yeah, yes. I mean, CBCPC.
Okay, what's the reason that the 2 triangles? So I have triangle ADC congruent to triangle BCD. Reason.
Angle or sine.
Side angle side. So AC is congruent to BD,
Through
CP, CTC.
the last step, you don't do a rectangle. ABC.
No, because that's what we started with, right?
Oh.
That's what we had to prove. We had to prove those 2 sides were congruent based on the fact that we had a rectangle. Okay. Okay, now some applications. Okay, we have ABCD is a rectangle. If AC is 3D minus X and BD is 4X minus 60, how do we find the value of X?
30 minus x equals 4x
Make-
minus 60.
They're going to make them equal to each other. So 30 minus X is 4X minus 60. So here we get 90, add X, we get 5X. 90 divided by 5. Aaron, guys,
18.
Nice one.
confirm.
Aaron, 120.
Okay. All right, we got another rectangle, MNQR. If NR is 2X, Simon, I will move you.
To where?
No, up front.
That's your
We have lots of options in this one. Okay, this is 2X plus 10, and NP is 2X minus 30.
Wait, and R.
Okay, so the whole thing is 2X plus 10,
Oh.
and NP is 2X minus 30.
Oh, can we just
2x
cut
minus
it in
30.
half?
4x minus 60 equals 2x minus 30.
No.
No,
Just
2x
do
minus
2
30.
times
One,
Two-
can you do
2x
X?
minus
2x minus
30
30
equals 2x
plus
plus
y
Or you could do
equals 2x plus
Where are you getting a Y from?
Because you
Where
can
are you getting
substitute.
y?
just do
No, because you
Okay,
can't
listen.
you use another.
Isn't
Two
it
of
just
these-
2x minus 30 times 2 equals 2x plus 10?
We already
I was gonna use y as another variable.
Or you
for
could just
PR.
do X plus 5 equals.
You could do the same thing. Okay, here we get 4X minus 60, 2X plus 10, so we get 2X.
Equals 70.
Thank you, Simon. X equals.
35.
Okay, now we want to find MP.
I wanna try this.
70. 70 minus 30 equals up.
Good. So remember, in a rectangle, all 4 of these segments are congruent. So NP and MP are the same. MP 40.
Yeah, and equals 40.
Can't you?
Question.
Isn't it 35 times 2 plus 10?
No, that would be. We just want this part.
Oh.
Okay, we got another rectangle. Find the values of x and y.
I don't like
Where
it's like
can
y squared in this case. It's just like throws me off.
Okay, well, we can.
4x
Y
plus
squared
nx
minus
plus 12 equals 90.
Yeah, so what do we know? These angles have to be congruent.
4y
So,
plus 4 equals y squared minus
okay. And these two have to add up
So
to.
it's like 4x plus 9x plus 12 equals 90.
Okay, so y squared minus 1 has to be equal to. Okay, whenever we have a square, we have a quadratic. We want to move everything to
So you
one
make it
side.
0.
So we have y squared minus 4y minus 5 equals 0.
So you have to find what times -5, what adds up to -4. So I'm
Okay.
gonna go with -5 and +1.
If you don't mind, can you please-
Okay.
And then
Okay.
All right, Simon. Okay, Simon, let everybody work it out. Give it a moment. Okay. So, yes, multiply. So, just a quick reminder when we're factoring quadratics, we want them to multiply together to give us the last number, the -5. They have to add up to -4. So, one has to be negative, one has to be positive. Our only options here are -5 and +1. Now, we're going to set each of those equal to 0.
but then when you positive
So, y plus 1 equals 0.
so y equals 5.
Now, I want to double check and see if I have both of these as solutions. Remember on the quiz, some of you put 2 answers, but only one of them worked.
It can
So
be
5 is fine because that'll just give us 24. But if I plug in -1, I'll get an angle of 0. So we're going to cross that. Yeah, some people like switched them around and some people got like the wrong sign. Okay, here we get 13x equals 78. Okay, 78 divided by 30.
Oh, 6.
I think someone beat you too at that time. It's okay. We don't have to be the quickest. We want to make sure we're accurate. Okay. Okay, one more of these and then we have another page. Okay. PQRS is a rectangle. We only have one angle measure. Angle 1 is 35. So this, okay, now Simon. Let's let everyone, give everyone a chance to think about this first. Okay. Okay, so 1 and 2 have to add up to 90 degrees. So 90 minus 35 is 55. Okay, so 2 is 55. Okay. 6 is 35 because these two are alternate interior angles. So
535. I mean, wrong way. Yeah.
okay, what do we know about the diagonals? They are congruent and they bisect each other, which makes all 4 of these segments congruent. So what do we end up with? We actually have, we have an isosceles triangle here, isosceles triangle here.
So 3
Isosceles
equals
triangle.
55
So
also.
if this is 55, 3 has to be 55.
And then 4 has to be 70.
Yes, so these two angles add up to 110. So 4 has to be 70 in order for them to add up to 180.
And then 5
Now
has to
4 and 7 make a linear pair, so 7 is 110.
be 8 is 30.
And then 70 has to go like on the opposite side because of vertical angles. But it's an isosceles triangle, so the other two have to equal 110, so 8 is 55 also.
8 is 55 also. And 5 has to be 35.
I said that one.
So in a rectangle, if you are just given one angle, you could figure out all the other angle measures. Okay?
How'd you from 8? She did supplementary and then she solved 35 plus 10.
You see it?
Yeah, there's 40, 35 in it.
Yeah, because this is the last. Okay. This is the converse of the previous theorem. So this basically just says if the diagonals of a parallelogram are congruent, so if you already know it's a parallelogram, if the diagonals are congruent, then we know it has to be a rectangle. Okay, so we want to determine, so we're going to actually use this above theorem to prove that. Okay, so we'll prove whether it is or is not. So D.
I'll let everyone else get this one.
What?
I'll let everyone else try this one out.
-2, -5. Let's see. 4, -2 is G. Okay.
Can you do
Okay, we got.
the midpoint theorem?
Okay, we could do midpoint theorem, but that will just prove if it's a parallelogram. Okay, we got two
Can
options.
we do slope?
We could do slope, and we could show that all the angles are, all the sides are perpendicular to each other,
Or you can do
like all the
distance.
consecutive angles. Or we can do the distance from H to F and the distance from D to G. So we either have to do slope 4 times or distance twice. It's about the same because slope formula is easier than distance, but distance formula we would only have to do twice.
It's like if the slope of DH and FG is perpendicular to the slope of
Not perpendicular. These would have to be parallel, but these. So
yeah, but those slopes have to be perpendicular to like the slope of DH has to be perpendicular to HG.
yeah. So if I do the slope of DH, okay, that'll be 2 minus -1. And then 2 minus -4. Okay, so that's going to give us 3/6, so that's 1/2. So then when I do HG, what should I get for my slope?
1/2. First.
-2. I need to get the opposite reciprocal. So if I do HG, that'll be 2 minus -2 over 2 minus 4. 4 over -2. Good. So that checks out. Then when I do FG, what should I get?
FG, you should get.
I should get 1/2. So let's double check. FG, so I'll have -2 minus -5 over 4 minus -2.
Cool.
3/6.
Wow.
Okay, and then DF, what should I get?
You should get -2 out.
I should get -2. So -5 minus -1 and -2 minus -4.
In this case, if I feel like if I just guess